Hello friends, and welcome to another session with edupediaworld.com, your favorite portal for online education. Continuing with regression analysis, this session we shall try to conclude this topic by taking up a few problems for practice. If you recall, in the previous session I had given you a question for assignment and it was for you to solve. I had also promised that we'll be solving this together in the upcoming session. So today let's start with this very same problem which goes this way. Obtain the two lines of regression from the following data and estimate the blood pressure when age is 50 years. Can we also estimate the blood pressure of a person aged 20 years on the basis of this regression equation? Discuss. So here we have the data of blood pressure of certain number of people with their ages. We need to estimate the blood pressure of a person whose age is supposed to be 50 years. And further, we need to discuss if the blood pressure of a person aged 20 years can also be estimated based on the regression equation which we find here. Well, so let's proceed. Let's put the data in an Excel sheet as we have here, and let's proceed with our calculation. Of course, we'll be using a shortcut method for which we need a u, and this time let me take u as the value x minus one of the values here in between. Let me take it as 52, and v would be equal to y minus a middle value, let's say 125. Well, we know that we can take any of these values, preferably a middle one. Now here I have taken 52 and 125. Okay, further I need the product of these two, so that will be u times v, and then we need the square of u raised to power 2 and v raised to power 2. Okay, so the first column, x minus 52, x is 56 minus 52, and similarly v is y, which is 127 minus 125, and then the product of u and v will be the product of these two numbers here. U raised to power 2 is 4 raised to power 2, and finally v is 2 raised to power 2. Well, we have all the formula set right, so let's drag it down to the last cell of this table, and here we have all the required data. Okay, so next I need the sum of all of these. The sum of these, the formula is sum of the values from the first till the last in this column, and I can drag this formula to all the remaining columns. So here we have all the required sums. Next I need to find the average of x and y. Average, either we can use the shortcut method, or we can simply take the sum and divide it by the total number of data. The sum is 630 divided by the number of data. Here we have 1 2 3 4 5 6 7 8 9 10 11 12, so n is 12, and here we have the sum of the average of x and the average of y with us. Fine. Next we need to go about finding the value of b. So b, if you recall the formula, it's n times, let me put it in parenthesis, n is 12, n multiplied by summation uv, which is this value, minus summation u times summation v. Okay, and this time summation v is 0, so of course when you solve it manually, this part will become, this part will become 0, and of course your solving will be easier anyways. So this is the numerator divided by the denominator, which is n times, n is 12, n times summation u square minus summation u the whole square. Okay, so here we have the formula for b, and solving this we get the value of b as 0.72. okay, we know that we can round it down to the two decimal places, so the value here for b will be 0.72. Next we need to find the value of a, and a, we know the formula is y bar is here, y bar minus b times x bar, right? Yeah, so that's the formula, and here we get the value of a as 87.077, so 87.07. okay, now do we need to find the other regression coefficients? Of course it's not needed, but let's do it just for the sake of practicing the process. So d, we know, would be equal to, and of course we know that the value of d will have these things common what we have here, only the second part of the formula so it's n times summation uv minus summation u times summation v divided by n times summation v square, which is this one, summation v square minus summation v the whole square. Okay, and the value of d is coming to be 1.17. Since it's 179, we can also write it as 1.18. okay, and then coming to c equals x bar minus d times y bar. Okay, and the value of c is coming to be minus 94.93, which can again be approximated to minus 94.94 or minus 95. Well, so now we have all the values a, b, c and d. Let's write the equations. Do we need to find the value of r? Of course it's not needed here, but let's just see what will be the value of r. The value of r simply is square root of these two numbers, the product of these two numbers, b multiplied by d. Okay, and the value of r is coming to be 0.92, which shows that it has got a very high correlation, positive correlation. Alright, so now let's write the equations here. The equations we will have is, now here if you look at the question, if I assume that the ages here is x, let me call this as x and this as y. So what I need to find, the age is given in this case, when the age is 50 years, so the value of x is given, we need to find the value of y. Therefore for the question I need this equation, y equals a plus bx. Okay, so let me pick the values of a and b. The value of a is 87.2 and the value of b is equal to 0.72. Therefore my equation now would be y equals 87.2 plus 0.72 times x. Fine. So this is my first equation, the regression equation, and then when x equals 50, that is when the age equals 50, what would be the value of y? Then y would be equal to 87.2 plus 0.72 times 50. And when you solve this, the value obtained will be 123.2. Therefore the blood pressure would be equal to 123.2 when the age equals 50. Okay, so that's the answer of the first part of the question. That is this part. Fine. And if you look at the data, when the age is 56, it's 127, 42 it's 112. It's very much in line with what we have present in the data, okay, in the range. Now coming to the second part of the question, the second part says, can we also estimate the blood pressure of a person aged 20 years on the basis of this regression equation? Well, what do you say? Of course, when you put the value here, that is when y equals 87.2 plus 0.72 times 20, right? When x is equal to 20 in this case, let me write it here. When x equals 20, then the value of y will be equal to, when you calculate this, this equation, it will be equal to 101.6, right? But then we know, practically we know that the blood pressure of a person aged 20 is usually normal, okay? Usually if only in the range, when it's above 40 or 45, the blood pressure actually starts fluctuating, either it goes high or low and so on. Whereas for a person aged 20, that's not the case. Therefore we cannot and we should not use the same regression equation for estimating this value, okay, because it has a range and we know practically that this is usually not true. And we know that the blood pressure of a normal person, if we assume that this is a normal person, then we know that the blood pressure of a normal person does not go below 110, right? It does not go below 110. It doesn't go less than 10. Therefore we cannot, and this result reflects the limitation of regression analysis with regard to estimation or prediction. Obviously, when you do this, you will have to look at the practical aspect also. It's important to note that the prediction based on regression line should be done only for those values of the variable that are not very far from the range of the observed data, okay, which is used to derive the regression line. So if the range we see here is maybe somewhere around from 32 goes up to say 72, 39 to 72. So in this range, of course, it will work. Beyond this range, it will not work. The prediction from a regression line for a value of the variable that is far away from the observed data is likely to give inconsistent results like the one which we obtained here, okay. So we shouldn't go much beyond the range which we have taken. Alright, so that is the question which we had taken in the previous session, and this is the solution for that. Let's move on and let's take some more variety of questions and solve them. Here we have the next one. Here they are asking you to find the mean of x and y and the coefficient of correlation between the following two equations, okay. So they're asking you to find the means of x and y, that is x bar and y bar. This is the first part, okay, and the second is coefficient of correlation r between x and y for the following two regression equations. Well, we have two regression equations this time given instead of the data. Okay, so it's something reverse of what we used to do. We have the solution and we need to go back and get the means and the regression the correlation coefficient. Alright, so in these cases what we do is we take one equation at a time and we assume, since there are two equations and we know that one of these would be an equation of y on x and the other would be for x and y, and we know that regression it can't be reversed. Okay, if this is for y on x, it will remain for y on x, and if this is for x on y, it will remain as x on y. We do not know, so the only way is we'll have to assume and we'll have to go by way of trial and error. If it works, fine, otherwise we'll have to change the reverse the assumption and pick the other one. So let's assume that the first equation is y depending on x. Okay, and the second is the equation of x on y. So let's take the first one now. 3y minus 2x equals 10. Let me rewrite it in the form of, you know, y on x, that is y equals a plus bx. So let's keep y on one side and rest of the thing to the other side. So we'll have, you know, 3y equals 10 plus 2x, right? And then y would be equal to 10 by 3 plus 2 by 3x, right? And if we look and compare it with the standard form, then we see that this value is supposed to be the value of a and this is the value of b. Okay, so this is supposed to be b and the first one is supposed to be the value of a. In the same way, let's take the second equation, which is, and let's write it in the standard form as x equals c plus dy. So let's keep x on one side. We'll have it's minus x equals minus 50 will become 50 minus 2y. Okay, and then when we take the minus to the other side, we'll have x equals minus 50 plus 2y. So again here the value of c will be minus 50, okay, and the value of d would be 2. Right, so now we know that there is a relationship between b and d, and that's given by r equals b into d, the root of b into d. So let's see, let's take these two b and d and see if this is, and we know that the value of r is always going to be less than 1, right? It should be between 0 and 1. Okay, of course we can have negatives, but then it will be between or rather let me write it as between minus 1 and plus 1. Okay, so let's take the product of b and d. We have b and d equals 2 by 3 multiplied by 2, which will give me 4 by 3, and we know this 4 by 3 is greater than 1. Therefore, and this is not possible, we cannot have b multiplied by d as greater than 1, right? Therefore our assumption is wrong. Let's see that our assumption is not correct. Therefore what we'll have to do now is reverse the assumption. Okay, of course there's no other way that you can get which equation is for is for y on x and which is for x and y. This is the only way. So let's now reverse the assumption and let's assume that, you know, your equation, this y equals a plus bx, that is equation of y on x, is the second one. Okay, that is 2y minus x minus 50 equals 0. So let's write it in the standard form. We'll have 2y equals 50 plus x, or y equals 25 plus 1 by 2x. Okay, so y equals 25 plus 1 by 2x. And then similarly in the second equation, let's take the second equation, which is to be assumed as x equals c plus dy, and that is this one. So it is 3y minus 2x minus 10 equals 0. If I keep the x part here, it will be 2x equals 10 minus 3y, or x equals minus 10 by 2 is 5 plus 3 by 2 y. Okay, so now my value of b and d, this is the value of b and this is the value of d. Okay, now taking them the product of these two, let's take b multiplied by d, and this time it's going to be 1 by 2 times 3 by 2, which is 3 by 4. And since this is less than 1, obviously the root of this will also be less than 1. So let's take the root of this, and when you take the root of 3 by 4, it's going to be 0.87. So this time I'm getting a perfect value for r, which is equal to positive value of root 0.87. Well, by this process we have found the value of r. Okay, and also we have got which equation is for which one. Okay, now next we need to find the value of the root of the average values of x and y. We know that the regression equations are valid at the averages also. Therefore, just by solving these two equations, you will get the values of x and y, that is the average value of x and y. So let's do that here. You have 3y minus 2x minus 10 equals 0, and the other equation is 2y minus x minus 50 equals 0. You have the first and the second equation. Solving for x, let's multiply the second equation by 2. We will have let me do it here. 3y minus 2x minus 10 equals 0. Let me write it as equal to 10, and here when I take the second equation and multiply it by 2, we will have 4y minus 2x equals 50 into 2 is 100. Okay, and when you solve this, we will have minus y equals minus 90, or y equals 90. So the average value of y is 90. Okay, so the average value of y is 90. Putting that in this equation, we will have in any of these equations, let me put it here, you'll have 2 times the average value of y is 90 minus x equals 50, right? So 90 to 2 is 180. When it goes to the other side, it becomes negative, so we'll have minus x equals 50 minus 180, which will give us minus 130. Okay, so minus x is minus 130, and therefore x will be equal to 130, and that's the average value. Of course, we know that the regression equations, or the line of regression, intersect at the point x bar and y bar, that is the average value. Therefore, of course, I can take both these equations for the average and solve them, and this is what I've done, and I've got the values of x bar and y bar. Okay, so finally my second answer is the value of x bar equals 130, and the value of y bar. In fact, this is the first answer, this is the first part of the question. The second is here, so it's y bar equal to 90. Okay, so that's the solution of this problem. Hope it's clear and easy. It's just the reverse of what we used to do previously. Well, just to consolidate your understanding, let's take a question, and this time you'll be solving it yourself. Okay, the question goes this way: in a partially destroyed laboratory record of an analysis of correlation of data, only the following results are legible. The variance of x is given as 9. Regression equations, of course both the regression equations are given to you, and then they're asking you the means of x and y. We have already solved this. The coefficient of correlation between x and y, and the standard deviation of y. So pause me for a while and solve it yourself. Alright, so now let me very quickly solve this question for you. Well, we have two regression equations, 1 and 2. Let me call them as equation number 1 and equation number 2. Okay, the variance of x, which is sigma x square, is 9. So the standard deviation of x will be 3, the root of this. Fine. And then the first that which we need to find is the means of x and y. Let's solve these two equations very quickly and see what will be the mean. Okay, you have 8x minus 10y plus 66. Let's solve it for, let's say, x. So let's multiply the first equation by 5, because 5 into 8 is 40. So we will have 40x minus 5 into 10 is 50y plus 5 into 66 is 330 equals 0. The second equation is 40x minus 18y minus 214 equals 0. Okay, so cancelling out the values of x here, we will have 50 minus 18 is minus 32y and plus, okay, so we'll have 32y equals 544, and the value of y will be equal to 17. Okay, just substituting that in any one of these values. Let me take it here as 8x minus 10 into 17 plus 66 equals 0 in the first equation, and we solve this for x. We will have, let me do this, 8x minus 170 plus 66 equals 0. So 170 minus 66 will be 104. Going to the other side will be plus 104. So 8x equals 104, or x equals 13. Okay, so the mean of x and y, the first answer, mean of x comma mean of y, will be equal to 13 comma 17. Okay, when you're actually solving this is for the means, where we'll have to change the equations this way. It's for the mean. Okay, so the first answer is the mean of x and y is 13 comma 17. Next, going to for the second one, the process. We'll have to take both of these equations and assume them as either dependent on x depends on y, or y dependent on x. So let's assume here that the first equation is y on x. Okay, equation 1 is y on x. So let me write it in that form. We'll have minus 10y equals minus 66 minus 8x, and this can be written as minus will cancel, all the minus will cancel. We'll have y equals 66 by 10, which is 6.6. let me write it as 66 by 10 plus 8 by 10x. Okay, so we are concerned with the value of b. This is the value of b, right? 8 by 10 is the value of b. Let me round it here. Similarly, let's take the second equation as x on y, so that will be written as 40x minus 18y, this will go to the other side, will be equal to 18y plus 214. Okay, so x will be equal to 214 by 40 plus 18 by 40x. We are concerned with the value of d, that will be this. So this is the value of b and this is the value of d. Taking the product of b and d, let's see if it is less than 1 or greater than 1. Okay, so when we take the product of b and d, this will be equal to 8 by 10 multiplied by 18 by 40. Okay, and when you solve this, 8 ones, 8 5 times 40, you'll have 18 by 50, 18 by 50, and that when you solve, it's coming to be 0.36. Voila, in the first attempt itself we have got our assumptions right. So this time the value of r will be the square root of this. Now r is equal to root under b into d, and we have the value of b into d, and since this is positive, we'll have the value of r also as positive. Therefore r will be equal to root of 0.36. okay, and that's going to be 0.6. so the value of r is 0.6. This is the second answer, the answer A and B. This is your A, the answer of A is here. This is the answer for B. Fine. And now the third part, they are asking to find the standard deviation of y, that is sigma of y. Well, we have another relationship, if you remember, where b equals r times sigma y by sigma x, right? Or d equals r times sigma x by sigma y. We can use either of these two because we have the value of b, we have the value of d, we have the value of r, and we also have the value of sigma x. So finding sigma y is simple here. Let's use any one of these two. Let's say sigma y, let's use the first one. Okay, so when we work this out, sigma y, let's keep sigma y on one side and remaining things to the other side. We'll have b times sigma x divided by r. So b is equal to 8 by 10, right? So 8 by 10 times sigma x is 3 and r is 0.6. So when you work this out, the value of sigma y will be 4. Okay, working this out, you'll have value of sigma y as 4. Therefore the answer for the third one, that is answer for C, solution for C, is sigma y. So you need to find sigma y here, right? Sigma y equals 4. Alright, so I hope with that you must have understood all of these, and now you are ready to solve any kind of problems on regression. Well, we'll take up further new topics and more problems in the upcoming sessions. Keep watching Edupedia World videos. Thank you.